Today's episode dives into three very different but equally exciting frontiers of AI: faster and more reliable video diffusion, smarter visual native search agents that can keep track of what they see, and tool-using systems that stay robust when the real world doesn't behave like the lab. From AnyFlow's any-step video generation to on-policy data evolution for multimodal agents, and finally to sim-to-real lessons for tool use, these papers all point to the same big question: how do we build AI that scales, remembers, and adapts? Let's explore the first paper, AnyFlow Any-Step Video Diffusion Model with On-Policy Flow Map Distillation. AnyFlow introduces the first any-step video diffusion distillation framework built on two-time flow maps rather than endpoint consistency mappings. The key shift is from learning Z, TZ0, as in consistency models such as RCM and self-forcing, to learning arbitrary transitions Z, TZR, along the probability flow ODE, which preserves test time scaling when inference steps increase. The method has two stages: improved forward flow map training, based on a mean flow style objective with interpolated time step conditioning, guidance fused training, and adaptive loss reweighting, and on-policy flow map distillation using DMD style reverse KL supervision. Its main novelty is flow map backward simulation, which decomposes a full Euler rollout into shortcut transitions using the composition property of flow maps, reducing both discretization error in few step sampling and exposure bias in causal generation. Experiments on 1-2. 1 backbones at 1, 3B, and 14B parameters show that AnyFlow matches or surpasses consistency-based baselines while continuing to improve with more NFEs. In CalSol text to video, AnyFlow FAR 1-2. 114B scores 84.05 on VBench at 4 NFEs and 84.41 at 32 NFEs, versus 83.25 for Kriya, real-time, 14B at 4 NFEs. In bidirectional text-to-video, AnyFlow 1, 2, 1, T, 2V, 1, 4B reaches 84.04 at 4 NFEs above RCM 1, 4B's 83.73, and in image-to-video, AnyFlow FAR 1-2. 114B achieves 87.87 on VBench, I2V at 4 NFEs, essentially matching 1-2. 1 I2V 14Bs, 87.71 at 50 times 2 NFEs. Let's explore the second paper, Towards On-Policy Data Evolution for Visual Native Multimodal Deep Search Agents. Towards On-Policy Data Evolution for Visual Native Multimodal Deep Search Agents identifies two core failures in current multimodal search systems. Tool-returned images are treated as disposable outputs, and training data is synthesized by static recipes that do not adapt to the policy being trained. The paper's first contribution is a visual native agent harness with an image bank reference protocol, where every original or tool-generated image is registered as an addressable is less than image. N is greater than handle, so later tool calls can reuse intermediate visual evidence. The harness unifies 9 tools, including web search, image search, scholar search, visual search, zoom in, rotation, flip, visit, and Python execution. The second contribution is On-Policy Data Evolution, a closed-loop generator that alternates task synthesis, policy rollouts, rubric-based trace analysis, and configuration updates with separate rubrics for supervised fine-tuning and reinforcement learning. Across 8 benchmarks, including MMBrowseComp, HLEVL, BCVL, VDR, MMSearch, MMSearch Plus, SimpleVQA, and FVQA, ODE raises Qwen3VL 8B from 24.9% to 39% average accuracy, and Qwen3VL 30B from 30.6% to 41.5%, surpassing Gemini 2.5 Pro's 37.9% agent workflow average on the same evaluation suite. Ablations show that reusable image state matters most on tasks requiring secondary image use, and that evolved data produces more grounded SFT traces and harder policy-matched RL tasks than a static synthesis baseline. Let's explore the third paper, When Simulation Lies a Sim to Real Benchmark and Domain Randomized RL Recipe for Tool Use Agents. This paper reframes tool use agent failure as a sim-to-real problem in a partially observable Markov decision process, where deployment noise can corrupt observations, action sets, reward relevant metadata, or transition dynamics. The authors introduce Robust Bench TC, a 3,721 sample benchmark built from BFCL v3, API Bank, Rote Bench, Tool Alpaca, and Tooleyes, with 22 perturbation types grounded in verified production failures from LangChain, Llama Index, OpenAI agents, MCP servers, and related systems. Across 21 models from 1, 5B to 32B parameters, the robustness gap is highly asymmetric. Observation perturbations reduce accuracy by under 5 percentage points, but reward perturbations cut accuracy by about 40 points, and transition perturbations by about 30 points. Scaling alone does not consistently help. Their toolRL-DR recipe applies domain randomized GRPO on Qwen 2, 5, 3B. Instruct using perturbation-augmented trajectories for observation, action, and reward types only. Compared with the clean 2RL3B checkpoint, 2RL-DR full closes 11.9 points of reward gap and, unexpectedly, 8.4 points of transition gap, corresponding to roughly 27% transition gap closure without ever training on transition errors. The paper argues this transfer comes from a more persistent retry policy, evidenced by a drop in omitted tool calls from 47% to 34.2% on transient error cases. The release also includes a public Hugging Face leaderboard, and open code, dataset, and checkpoints. That's a wrap on today's AI paper highlights. Thanks for watching.